What's up, everybody? It's Time Safdar, and you are listening to the CloudNative.fm podcast. I'm excited and thrilled to host this show for you. This is episode number 10 of CloudNative.fm podcast. Today is April the 15th, 2021, and in this episode, we are going to talk about how to prepare for Kubernetes Pod Security Policies Deprecation with Kyverno, with my guest Jim Bugwadia. Jim is the founder at Nirmata, a San Francisco Bay Area startup in the enterprise DevOps space. Jim has been building large-scale distributed software systems for the last 2 decades. Jim started his career developing C++ software at Motorola for the cellular network infrastructure, where his team launched the world's first CDMA network. Since then, Jim has held several developers, architect, and leadership roles at companies like Bell Labs, Cisco, Rapid Z Network, and Panologics. In 2013, Jim founded Nirmata, a startup focused on solving enterprise DevOps pain points by providing multi-cloud management of microservices-style applications that are deployed using containers. He is also a maintainer and maker of Kyverno tool. If you want to see what he is up to, follow him on Twitter at Jim Bugwadia, JIMBUGWADIA. And let's go ahead and say hi to Jim and cut it over to the interview.
Thank you everyone for joining us today, and this is CloudNative.fm podcast, and I'm your co-host for this podcast, Saim Safdar, and today we are talking about all things on Kubernetes Pod Security Policies with my guest, who is the maintainer and who is the creator of Kyverno projects. And Kyverno is a project from Nirmata company, which is a management platform for the Kubernetes. So thank you very much, Jim, for showing up today. How are you? And thank you very much for joining me today.
I'm doing great, Siam. Thank you for having me. Very, pleased to be here and looking forward to discussing pod security policies, Kyverno, and everything else.
Thank you. So can you introduce yourself to the audience, where you currently live, what your projects are, and what you are more enthusiastic about in Kubernetes ecosystem? What are the projects you are currently working on?
Absolutely. Yeah, so my background, I come from a software engineering background. And as you mentioned, I'm a co-founder and the CEO at Nirmata. And what we do at Nirmata is we make a management plane, a management platform for Kubernetes, which is completely SaaS or cloud-based, can also run on-prem. And policy management is a big component of that. And I'll talk about how some of the work we were doing with our customers led to the creation and the ideation of Kyverno and how some of the patterns have evolved. But just to kind of complete my background, so I live in San Jose, California. I'm originally from Bombay, India, now called Mumbai, and moved to the United States back in the late 80s, did my college degrees, my education here, worked in around Chicago. So I started my career doing distributed systems, but very different from what we know now. At that time, so I worked on cellular telephony programming, of course, like if you think about a cellular network, a telephone network, it is a very distributed system with several HA components and extremely complex, sort of network and topology, right? So I started doing, some software development in C++ at that time, in those type of systems. And then, of course, as the internet kind of got created and started, becoming popular, moved into networking, did a lot of, net operations and management type of platforms for networking. And the whole idea behind Nirmata was, as every business becomes a digital business, and as more and more software becomes mission critical for every enterprise or every organization, right? So today, if your software is not running, it's almost as important as having electricity or having a utility. So because of that, we were looking for better ways for all of these enterprises to manage their software components. And that's the mission, that's our story at Nirmata. That's what we do, make it easy to manage software across different infrastructure stacks, using, of course, containers and Kubernetes and these technologies.
Yes, definitely. And I think the distributed system is a quite a complex topic when we think about in the past, in the decade past, when we don't have Kubernetes, when we don't have containers in it, we're not even thinking about very few people that have the guts in it to talk about the distributed system. But with the advent of the containers and Kubernetes came into the picture, now everybody is talking about the microservices patterns, and they are the go-to platform, go-to design pattern for every application that is running on the internet right now today. And I'm really happy that I'm joined by the expert who have this notion of understanding what the distributed system are and how they are different from the traditional system and why they are so important in the business, in the enterprise businesses we have. Can you introduce to our audience what is the pod security policies in Kubernetes and why do I care about them?
Right. Yeah. So in Kubernetes, as you probably very well know, a pod is the fundamental unit of packaging of operations and management, right? So Kubernetes, of course, is designed to run containerized applications. And in Kubernetes, instead of running a single container, you can package groups of related containers that have the same life cycle into a pod. Now, when you are scheduling a pod on a node, there's a lot of different security parameters which relate back to Linux containers, C groups, namespaces, things like that, even like host resources, how that pod is consuming host resources. All of this is configurable in Kubernetes, right? So in the deployment spec or in the pod spec, there are constructs like things like a security context, which can be configured at a container level, and then for the overall pod. Now, this security context has several different tunables, several parameters, and a lot of these are fairly advanced, right? In most workloads, you don't need to worry about these. You don't need to set these. But the pod security policy construct is a Kubernetes resource which was designed to control these parameters in the pod security context and in the container security context. So what happened was pod security policies were introduced in Kubernetes. I don't remember the exact version, but something like 1.14, 1.15, but they have stayed like in alpha and beta state for a long time. And the reason why they never graduated was because they were difficult to use in production. And the pattern in how you associate a pod to a workload used, the way it was implemented, it used, authentication or RBAC authentication type of rules, and you would set up roles for your workloads to associate them to pod security policies. So that imposed another layer of challenges in how these could be configured and managed, because in reality, in most systems, you're not running pods directly, but you're running a deployment or you're running a stateful set or a job, and those execute, pods underneath. So all of this complexity led to, the thinking that there needs to be a better way to make Kubernetes secure by default. There needs to be some baseline, security guidance that everybody in the community can use, and not have to deal with this complex configuration to secure workloads, right? So the decision was made in the community, and this is, driven by SIGAuth, SIG Security. So these are the, different, Kubernetes working groups and special interest groups, who are in charge of, some of these features. And, after a lot of user input, after a lot of discussions, the decision was made to deprecate pod security policies and replace them by a different entry construct, which will be more easier to use, which will be label based. So, and it will be at a namespace level. So the idea would be at a namespace level, you can assign different privileges, and that makes it easier to have some standard security by default. But then you will still need to do additional controls on in top of this in terms of how you want to configure your workloads, right? So if you want some fine-grained permissioned, if you want to say in this namespace, maybe only my Nginx pod is allowed to use host path, right? Those type of things you would still want to control through an external out-of-tree policy management tool. So that's where there's a lot of discussion going on, and that's kind of also leading to a lot of interest in Kyverno, is to say, okay, so the pod security policies are deprecated as of 1.21, which is just released today, right? And it's now out and available. And once that has happened, if I'm bringing up a new cluster, whether it's production, whether it's a dev test cluster, I want some baseline security for my cluster. So what is the easiest way to achieve that? And then grant exclusions as possible. So, folks today of course, have to decide what to do today. And then once there's more entry, other replacements to PSPs available, then they can decide whether they, switch to that. They continue using policy engines like Kyverno or Gatekeeper OPA, which is another policy engine, and how they combine the usage of these to make sure that their security concerns are met properly for all of their clusters and workloads.
Yes, definitely. And on the topic of pod security policy, we all know that the containers are essentially the virtual operating system. So we have IPCs and network namespaces with a port mapping and these kind of stuff. So I have to package that up, that my containers or the pod I'm running at, they have some kind of privileges assigned, so that no other user can get to the root access to the container, and then they can use the underlying host operating system into that. So I need something so I can control the workload that I'm running on top of Kubernetes in a container. So I can strip the rootless access and other kind of stuff. But on the topic of pod security policies, I often can think that people are also confused with runtime security of it. So how it is different from the container runtime security, and how it's what the idea of pod security policies and what the idea of container runtime policies.
Right. A good question, right? So pod security policy is one aspect of the overall security posture, right? It's not everything, but it's a very important aspect, right? So certainly in addition to, pod security, you want to do the basic stuff, like you want to make sure that your images are scanned for vulnerabilities, because if there's a vulnerability in your container, somebody could still potentially leverage that exploit and then get, into the pod file system. If they can get to the pod file system and the pod is running as privilege, then like you mentioned, they can potentially get into the host file system. And once they get into the host file system, from there, they can kind of do other things, right? So there's several layers, of course, in these to be secured. And when you think about runtime security, there's also concerns like network segmentation, right? Because if you're running different applications, you want to make sure that only, even things like denial of service attacks and other things, you need to make sure that only the authorized, or trusted endpoints are able to communicate with your endpoint, with your application. Your application is only making calls, or things from your namespace are only making calls to allowed, external IP addresses, things like that, right? So there's many other items with runtime security. There's also tools, of course, like Falco and others who are detecting, for example, if somebody in your cluster does like an SSH access into a container. Those are events you want to detect, you want to audit, and you want to make sure that you have some prevention against that. So pod security policies don't manage all of that, but they manage a very essential component of security, because everything in Kubernetes, like we were talking about, runs as a pod, runs as a container, and by securing that level, you're definitely cutting off, even if somebody gets access to the container, you're cutting off access from that container if you're, based on your security configuration and parameters into other aspects of the system. So it's an important component, but it's not the only thing to think about. Runtime security is still important.
Yes, definitely. Because I think in the world of containers and orchestration, we have three layers. One layer is called the host operating system that you want to secure by default, but you are able to take control of. The second layer is a container layer that you want to access. And other layer is the cluster administration layer that you want the cluster to not take control of somebody else, take charge of your cluster and then put malicious activities into your cluster, and you can do anything you want, because at the end of the day, containers are essentially the virtual operating system, and they have all the construct of operating system inside the containers that we already have. So now the next question, and the next question from my side is, what are the best use cases to implement Pod Security policies in Kyverno? Because we have right now two options. One is called OPA Gatekeeper and one is called Kyverno. So can you elaborate this topic? What's the best use case to implement it in a Kyverno?
Right. Yeah, so Kyverno follows something known as Pod Security Standards, right? So on the Kubernetes blog, on the Kubernetes documentation site, if you go, look up Pod Security Standards, that is a published document. It's been out for a few releases now. And in fact, PSPs or Pod Security policies are an implementation of that, Pod Security Standards. So Kyverno's approach is to follow the same Pod Security Standards. And we have a ready-to-go policy library. If you just go to kyverno.io, click on policies, you will see Pod Security Policies as one of the first entry. And then they are organized by baseline or default, which is the first level. And that is the recommended, level of security that you should run by default, like the name indicates in your cluster. And then there's, also restricted, which is a higher level of security. So wherever possible, the recommendation is to run restricted, and then to grant other access or other levels of access to certain namespaces or certain workloads if those pods require, other privileges, right? So there might be some very good use cases why maybe in certain case, for certain pods, you do need to allow higher privileges. But then with Kyverno and with, controlling this, you can now separate that pod into its own namespace, and you can then assign that higher privileges just to that workload, right? So the best practice recommendation is use namespaces, use microsegmentation as much as possible with your workloads, because a namespace is the true security boundary over here. Once an attacker gets access to the namespace, they have access to all of the secrets, all of the privileges assigned to any workload in that namespace. So really the best way to do this is microsegment your workloads, use namespaces correctly, and then based on those, which workloads require higher privileges, assign Kyverno policies based on those namespaces. So Kyverno makes this, you mentioned, there's the two alternatives, OPA, Gatekeeper, and Kyverno. There's also, some other, of course, there's commercial tools which also can, do this type of security. But if you're looking at policy engines, admission controllers, in Kubernetes, like you said, these are the two, fairly popular options these days. And the value proposition of Kyverno is your policies are written as Kubernetes resources. So there's no new language to learn, no external system required to kind of, even write these policies, customize the policies. Kyverno fits in extremely well with GitOps style workflows. So if you're using, Flux, or if you're using, Argo CD, or even Nirmata, or any other kind of, or Rancher's Fleet, any other kind of GitOps controller, those, Kyverno policies just are a Kubernetes resource. So you can apply customize to them. You can, put them in your GitOps pipeline. Kyverno also has a integrated command line tool. So you can even check for these policies and the security constraints before they're applied to the controller or to the cluster. Now, once they're applied to the cluster, You can block configurations using Kyverno. So if somebody is trying to run a privileged pod in a non-privileged namespace, you can easily detect and block that. And then you can also, if you want, you can mutate things. So Kyverno has a very powerful capability of mutating and generating resources. So you can change on the fly if you're, let's say by default, you want to inject a security context and you want to say, pods should only use root file system with read only. That can be done by default across the board without having, your developers to write all of these parameters into their YAMLs, right? So lots of flexibility, but the easiest way to get started is look at the pre-built policies available in the Kyverno library, just at kyverno.io, and start with the restricted profile, and where necessary, then apply the baseline profile with slightly less privileges.
Yes, awesome. And also, I think on the point of how it's different from the OPA gatekeeper from Kyverno is the potential it's give you. You don't able to learn the new language, because the gatekeeper by default uses a regular, and people are asking. We are already surprised by the YAML that we are learning. In every child, we have a pod for YAML, we have a deployment, stateful set. Kubernetes has YAML every place in it. Now I have to learn the new languages, but I don't want to do that. And the Kyverno is the best place for you if you don't want to learn, because it treated the pod security policies at the native resource in Kubernetes, and you don't able to learn the new languages. This is how I think it's different from the OPA gatekeeper. So the next question is, can you explain this in detail? What is a typical dev workflow when we're using Kyverno as a PSP?
Yeah. So for developers, I think the best, or the recommended workflow here is, of course, to use Kyverno early in the whole dev test CI/CD lifecycle, right? So if you are, doing microservices style development, if your repositories already contain YAMLs for your deployment or your stateful set or your other controllers, then what you can do is you can use Kyverno as part of your, in fact, through the community, we already have contributions on GitHub, like pre-commit hooks, things like that, to apply Kyverno directly when you're creating a PR, right? So at that time, you can validate your YAMLs. You can make sure that they're compliant to your enterprise's policies for pod security and even other policies, right? So a lot of our users may do things like they might say, okay, every workload requires some standard labels. Every workload maybe has to configure quotas and things like that. So all of these policies now you can easily apply in your CI/CD pipeline, and your operators can set up these policies. They can be applied as early as during when a PR is raised, and developers of course have to now make those changes in order to kind of pass that gate and to be able to submit their PR or to be able to get their YAMLs accepted, right? Now, beyond that, the other entry points for Kyverno, so there's three phases. There's the CI/CD pipeline, there's admission controls. So admission controls is a very interesting thing in Kubernetes, because everything in the Kubernetes world works within a cluster. All requests go through the API server, and the API server is designed to be extensible. So Kyverno registers itself as a validating and mutating webhook, which means that every request that comes to the API server gets forwarded to Kyverno. And based on your policies, Kyverno builds up an internal cache. And it's extremely fast. There's a 3-second deadline to be able to look up a policy, apply a policy. And when an API server makes a request, it will either block that request and say, this is not allowed in production clusters, or it can mutate that request and say, okay, I'm going to allow it, but with these additional security parameters, right? So both of those can be done at admission control. Kyverno can also, for certain requests, once that request is made, it can allow that request and then use it as a trigger to generate more resources. For example, when you create a new namespace, Kyverno can automatically then create a network policy, quotas, role bindings, all of this for that namespace. And in fact, again, if you go to the Kyverno policy library, click on multi-tenancy, there's a set of built-in policies that we recommend for multi-tenancy. Those are already available, right? So that's the second place where Kyverno policies get applied for clusters. Finally, Kyverno also runs periodic background scans, because it is possible, there are always, like I think it was, Werner at Amazon who said, in a distributed system, everything that can go wrong will go wrong, right? So if you assume that. So in case somehow, your admission controls are bypassed, Kyverno also runs background scans to detect, any violations inside your cluster, and will report these. So the reporting in Kyverno is also a Kubernetes resource. There's something, it creates a policy report, and in fact, that report is, is being worked on as a, potential standard proposal by the policy working group in the Kubernetes community. So once you have that report, you can use standard tools to, display that report, share that report. Of course, you can use kubectl to look at the raw report, but there's also community contributions now to be able to display that report either in Grafana, in Prometheus. There's some native UIs being built by folks in the community. So lots of, interesting things happening and lots of way to share these security best practices and the results from Kyverno.
Yes, definitely. I think Frank did a tremendous job of creating the policy report in Kyverno, and it's been a very cool one. You can integrate in a Grafana and Prometheus dashboard, and he did a tremendous job. And hopefully,
absolutely.
And the next question is, when do we think about implementing PSP? Is it early in the software development life cycle, or when we move to the production, now we want to think about that? Now is the next job is to configure some pod security policies for containers or pods.
I would say early, right? Because some of this impacts how you design your containers. Because if you want to design containers securely, you want to make sure that when you're building your images, you're not using a root user ID. There are certain things that could also impact, again, what goes into your Docker file, things like that, right? So as early as possible. The other thing to kind of point out is a lot of times people think that pod security and all of these security policies, maybe I don't need those for dev test clusters. But you have to realize, if you look at the hacks and the attacks out there, the number one way people get access to corporate information, etc., is through dev test systems, right? So they will, if your dev test system is open and you get access to certain root resources, and somehow from there you're able to now find other passwords or other things, that's how people can follow that trail and get to other more mission critical or more important systems, right? So certainly this is not something which should be only done for production clusters, but should be done for all clusters. And with Kyverno, again, it literally takes about 10 seconds. If you install the Helm chart for Kyverno, it comes built in with some of the pod security policies. And it takes about 10 seconds to bring this into your cluster. So there's really no reason to not do this. And it's not going to impact your existing workloads. It's designed so that it will start reporting violations for your existing workloads. But new workloads which are insecure can now be prevented, right? So again, the reasons for not doing this early are sort of becoming fewer and fewer. Initially, of course, in the early days of Kubernetes, this knowledge did not exist. Tools like Kyverno and OPA Gatekeeper did not exist. And there were good reasons why people kind of said, okay, I'll think of it later because it's too complex, it's too difficult. But nowadays, with Kyverno and with other tools, this is simple enough. It is, very easy to secure your clusters to some default level, at least for pod security, right? So we definitely, recommend thinking of this early. The other thing is a lot of times people also say, okay, I only need this if I'm, sharing my cluster across workloads. But that's another myth, that's another misconception, because even if you have a single workload in that cluster, if you're creating a new cluster for each app or for each team, you still need to secure that cluster, right? Because again, even for that single cluster, you don't want someone to be able to, leverage that exploit, get to your root file systems, get to other, systems within your network or within your enterprise itself. So those sort of things have to be thought about early and should be applied across the board on every cluster.
Yes, definitely, because as we are talking about the distributed system, it's going to be very complex in a very small amount of time. Let's say you have one pod as of today, but when you wake up in the morning and you see 10 other pods growing up, and now you are thinking about why not I can secure my cluster, and now end up you having the 10 pods and you have to run the scans of policies in it, and then you invalidate their reports, what they are doing, what they're so end up we have very complex system at the end of the day. And if we don't think about still early in the dev life cycle, it's going to be a very complicated when we're moving to the production side.
Right.
And also the next question is, how do you think it helps the Kubernetes cluster operators? Because I think cluster operator is a job in itself in Kubernetes.
Absolutely, right. So yeah, and what we see even with Nirmata customers is there's typically a small platform team, admin team that manages the clusters. And not only do they manage the clusters, but they also have to manage all of the core packages. So just think about like today, if you work in an enterprise, if you work in a business, if you ask your IT team for a VM or a laptop, right? They will give you a laptop, but that laptop comes pre-configured with all of the standard corporate packages, right? And maybe you can go to some store, maybe in an internal catalog, you can install some other packages which are approved by IT. So similarly, clusters are moving in that same direction. When you get a cluster from your IT team, from your platform team, from your admin team, the cluster needs to be running security, monitoring, policies, logging, maybe compliance checking, several other tools. So there's about half a dozen to a dozen of these tools, add-ons, which need to be run on every cluster. And who's responsible for upgrading these add-ons, right? I mean, developers are concerned with their application. They're not going to be responsible for, updating these type of add-ons for, security, monitoring, logging, etc. So the central team manages the cluster upgrades, manages the add-on upgrades, manages the policies, configures also when somebody gets the cluster, you don't want to necessarily give the development team cluster admin. So there needs to be some other role created which allows them to create namespaces, manage their workloads, but not go and completely, set up or completely change RBAC within the cluster. So those sort of things, there's a split between what a cluster admin does and then what the application team does. So Kyverno is designed for that, a policy. First of all, even without Kyverno, the thing that we realized about policies, a policy is really a contract between that admin and the developer, right? So it's a digital contract, if you think about it. And in Kubernetes and in Kyverno, you are writing that contract as YAML. You're expressing that policy as a Kubernetes resource and saying that as an admin, if you're using the cluster, these are some of the rules that you need to abide by, right? And that's what the beauty of policies are. It's this handoff between dev and ops. And it allows each dev and op role to do their jobs, to do it securely, to do it in a scalable manner without having, and in an autonomous manner, without having to kind of always, wait for one side or one other side to do something and complete something. It becomes fully automated. It becomes a contract between dev and ops. So that's where we feel Kyverno policies mostly are written by cluster admins and for the cluster. Kyverno also supports namespace level policies. So if you, as an application owner, you want certain policies for your application, you can do that, right? You can write more policies, and we're seeing that, applications running Istio and maybe services. Maybe they want to write a policy that when a service is created with a certain label, maybe they're generating other configurations, for that application or that workload. So you can also have policies at that level, but the most common use case is policies which are cluster-wide, which are designed by the admin team, and then used by the development teams. So the one thing we designed in Kyverno is to make sure developers get the right feedback. So Kyverno policy reports that we talked about are namespace level. So one of the problems with other tools is developers can't see the error. They don't know what to fix. And if I don't know what to fix, how can I improve my workload, right? How can I change it? So in Kyverno, we kind of took the approach that all of this has to be available to developers in a very easy manner. So I know exactly what to fix in my workload. Like a compiler tells me what I should fix before I commit my code. Similarly, Kyverno will tell you what are the things you need to improve, what policies you need to abide by before you can submit your YAMLs. And also you can see these as events. You can see this if you go into your pod, if you do a describe pod or describe deployment, Kyverno events will show up. It will tell you exactly what was changed. So we want to make sure that that developer experience is very good, because ultimately it's the developers who are the end users of this. So it's the administrators who are defining the policies, but the developers are the ones ultimately using this and using the policies to improve their workloads.
Yes, and see, the role-based access control is a topic of interest to everyone, because in a Kubernetes cluster, somebody has some privileges, and the least privileges so you can do their work. So others' work is not interrupted by their work, and we don't have conflicts going along the way. So we have a role-based access control in it, and with Kyverno, you can do that in a very, very easy and simple and in an awesome way. And also we see in the Kubernetes landscape, we have distros, so many distros like K3s, Kind, Minikube, MicroK8, K0s, another one is coming up. How do you think that in the future they have built-in feature of Kyverno in it? So you have some plans for communicating with their team, so you can have some built-in. So none of my job to go in the K3s cluster to configure the Kyverno, but the K3s cluster by default has some Kyverno in it. Do you have some discussions started in the Kubernetes ecosystem?
So there are folks doing something like this, but they're using, again, infrastructure as code, best practices to maybe have Kyverno installed by default, right? So in fact, even the Flux2 project, they are using Kyverno for multi-tenancy use cases internally. And if you go to the Flux2 docs and search for Kyverno, you'll see some of the policies that they have configured. So Kyverno works very well with IAC, as well as if you want to apply policies as code. So certainly it is possible that once you bring up these systems, by default, if you're using infrastructure as code, to bootstrap and to install any distro, by default, Kyverno would also be installed as one of the base packages, as one of the add-ons. If you're using Nirmata, of course, we automatically do that. Because we use also Kyverno for multi-tenancy, for generation, for generating configurations, things like that. If you're using other systems, it would depend. Today, it would depend on the delivery, how you're installing those sort of things. In the community, we do have users from EKS, AKS. We have users who are even GKE, of course, and other cloud systems. We also have users who are using you mentioned K3s, so we have several users who have and we know this because, of course, with every distro, with every system, sometimes there's issues with the CNI, there's issues that in the configuration. So we see some of these bug reports, and based on that, we understand what kind of environments Kyverno is being used in.
Yes, definitely. I see the first time I've seen the Kyverno is thanks to the Rancher community, and Adrian Goings is running at their Slack in their Discord channel, and they have thought about it. The Kyverno is coming up. It's a very fast way to spun up policies in the Kubernetes cluster. So on the topic of the distros, we talk about that we can have some leverage to build in package that up by default. Kyverno in the K3s cluster, the Kind cluster, the Minikube, MicroK8s, or even the K0s. And how do we think about, is it a add-on in the AKS or a EKS and GKE? Is there add-ons available for people's in the Azure dashboard, on Google Cloud dashboard, on the AWS dashboard?
Yeah, so I don't believe they're available in the, in the dashboards from the cloud providers yet, but it's extremely simple, just like any add-on that you add to your cluster. Kyverno can be added using either a Helm chart or just using the base YAMLs and customize and GitOps, right? So whatever your style of deployment is for your add-ons, Kyverno just works very easily with those. And we do have, again, all of these in all of these flavors, these managed Kubernetes services. Kyverno has been tested and validated, so it works. There are some, if you're bringing up a EKS cluster, there's some configuration options. If you go to our troubleshooting section, there's listed if you're using it, especially like CNIs like Cilium, and then you're using EKS. There are certain parameters and things which need to be set. But in most cases, in like 90+% of the cases, it just works seamlessly.
Yes, definitely. And on the topic of CI/CD, you elaborate this in a very detail that you can configure Kyverno in a CI/CD pipeline. But the last question on this topic is what to look for if we implement Kyverno as a part of CI/CD. It's meaning what to look for, what to watch out for if troubleshooting is happening or some leaks are happening in the CI/CD pipelines.
Right. Yeah, so certainly, the way we have organized policies in Kyverno, so we have pod securities, which we talked about in detail, pod security policies, but we also have a category of best practice policies. Now, those best practice policies are, most of them relate to workloads, where, how you would want to configure workloads before they go, into any cluster and especially to production. So things like, making sure that resource quotas, memory, CPU, things like that are there. Making sure that each workload has probes, for, to make it for the container health checks and things like that, right? So all of those are, policies are already available. So we definitely recommend taking a look at the best practice policies. You can, just fork the repo and you can kind of customize those for your organization, for your best practices. But it's all the reason, and a lot of these are coming in through community contributions. In fact, one of our customers at Nirmata also contributed a great policy recently where, they are checking for workload identities, right? Where they're making sure that if a workload is using a service account, that service account is, authorized for that particular workload. So some other workload in the namespace, like if there's a hack, if there's an attacker, they cannot use the identity of another workload, right? So these type of things are very complex otherwise to do, but with Kyverno, they're made very simple. And there's policy examples. The great thing is with our model at Nirmata, our business model, and with Kyverno, we don't, we want to make all policies available to the community, right? So we're not trying to say that, okay, if you want complex policies, if you want the real production policies, you have to pay, us to get that or anything like that. In fact, all of these are open to the community. They're shared by the community, and we're constantly adding more policies into the library, right? So because of that, we're seeing that policy library grow. There's about almost 50 policies available, which are all, highly recommended to look at. And we're constantly adding more. And in fact, that we've also added capabilities. All of those policies get used in the regression tests, in the testing for Kyverno. So once you contribute your policy, you're sure that this is being validated and tested with each upgrade, with each release at Kyverno. But yeah, going back to your question on the development and CI/CD side, definitely would recommend looking at the best practice policies, applying those, and customizing them to your needs based on what is best for your organization.
Yes, it's a very deep dive as we are moving from and learn so many cool things from you. But for the last thing that I want to learn from you, that want to understand from you, what is the future of Kyverno, PSP, and Kubernetes, and do we able to see more products from Nirmata Cloud is going to be popping up? The one is that is really popular and everybody talking about it, and it's a very simple, awesome, and has a ton of community support as well for the Kyverno. As Frank made a tremendous contribution, people are also making contribution, everyone. And if Frank is listening to us, they did a tremendous job, because developers like me are looking for these kind of policy reports in a development workflow. I not want to able to move that in the production side and then see, oh, there's 70 policies. I am using the policies, but all of them violated. But I want this in the development workflow, so I am very happy to see that. So the last,
absolutely.
So last question: what we see in the future of a roadmap of Kyverno? Do we see more Nirmata open source project coming up, and what is the future of PSP?
Yeah, so let's start with the PSP one first, right? So certainly PSPs, like we talked about upfront, also they have been now marked for deprecation, which means that PSPs are not going away right away, but with in version 1.25, PSPs will be officially removed from Kubernetes itself, right? And there will be, by that time, the plan is to have some in-tree replacement for PSPs. With Kyverno, we will support whatever the in-tree replacement is and how that's designed. And we will also make sure that Kyverno policies can work well with, of course, any new construct that is introduced for pod security. With Kyverno, we will continue to support the full pod security standards, and that's what's published today. So it's very safe for anyone to start with that pod security standards, start using them today, and then they can decide how they use the combination of the in-tree pod security construct, whatever that gets called, as well as Kyverno policies moving forward to achieve their security needs, right? On the Kyverno side, for the roadmap, there's lots of active features. In fact, we're seeing more and more maintainers and contributors from other organizations, not just Nirmata, right? So we have several other end user contributors. We have several other companies that are starting to contribute. In fact, there are other companies building tools now on top. Frank's tool, like you mentioned, which is awesome for policy reporting, is one example. But there's also other businesses now starting to kind of look at Kyverno and saying, okay, how do we just make this part of our product, part of our workflow, and what else can we build on top of it, right? And that's really the power of the community. That's the advantage and the benefit. And we're so glad to be part of the CNCF ecosystem in this awesome community, because we can kind of see some of those patterns developing. And the final part of your question on Nirmata, right? So absolutely, we already have other open source projects. They're probably not as well known as Kyverno. Like there's one project that we called Kubernetes, which actually is a eBPF monitor, and it can detect eBPF network connections. It kind of reports upstream into Prometheus. It's a very cool project, but it's relatively we've been heads down focused on Kyverno in the last few months. So we haven't promoted that project or talked about it much. There's also other projects. So Nirmata itself is written in a combination of Java and Golang. So we even have other distributed system projects on the Java side, which we have open sourced. We're continuing to open source other Kubernetes projects, as well as on the Nirmata side, our whole kind of approach is, okay, so if now Kyverno is being used or anybody is using clusters, what can we do for multiple clusters? What can we do for collaboration between dev and ops? So of course, as you go into production, there's several other things that organizations and businesses need. And that's what we focus on from a Nirmata roadmap point of view. So collaboration between dev and ops, handling multi-cluster use cases, and advanced use cases for not just like policy as code. We also support that through GitOps, but even going and customizing policies, generating new policies on the fly, things like that. So at that level of Kyverno usage, definitely, and Nirmata also has a free tier. It's available as a SaaS. So very easy to try out and kind of visualize your, what's going on in your clusters, policy management, workload management, even the cluster part of it, and then go into the multi-cluster and collaboration type of workflows.
Thank you very much, Jim. Really enjoy the whole this conversation with you today. And everyone who's listening to us, you got to be surprised to to heard about this, that we have already have some webinar is published on Cloud Native Islamabad channel, Securing Automating Kubernetes with Kyverno, and Jim and his fellow colleague shooting is tell you how awesome it is to manage Kyverno in a Kubernetes cluster and manage your policy in a simple YAML and Kubernetes native resource way. So go definitely check that out, and hopefully today we'll learn a lot from Jim discussion. And the topic you brought up is eBPF is a really shining topic in this cloud native network ecosystem, and I hope to connect with you on another podcast on the eBPF side as well. But today I learned so many good things from you, from the deeper dive of Kyverno. I heard about Kyverno is doing so many good things, but today I got a whole lot of 365 view of Kyverno. You can do it in a CI/CD way for the GitOps. On the rollback side, you can multi-cluster is also coming up in the roadmap. So many cool things is happening in the Nirmata side on open source projects. And thank you very much, and hope to connect with you, Jim, again in future. And thank you very much for sharing with me time with me today.
My pleasure. Thank you, Siam. Thanks, everyone.
Thank you. Bye-bye, everyone.
Hey everybody, if you want to keep up what's going on in the cloud native ecosystem, we have a weekly podcast show on YouTube and SoundCloud by the name of Cloud Native Islamabad. You can listen for free every single week. We try to find cloud and cloud native experts, share updates on cloud native best practices, cloud native real-world use cases, cloud native deployment patterns, cloud native deployment strategies. Topics include AKS on Azure, EKS on AWS, GKE on GCP, cloud native architectures, cloud native application developments, containerizing application, DevOps and automation, cloud native certification strategies, cloud native career tips, and more. So if that sounds awesome to you, head over to the SoundCloud and YouTube and subscribe to Cloud Native Islamabad.